Let's look at problem C. In problem C, we have a sub n equals negative 1 to the n times n. So again, they want the first 5 numbers in the sequence, so we'll try a 1, 2, 3, 4, and 5 for our n's. So that's what we'll plug in for our n's here to find our first 5 terms. So for the first term, when we do our a to the first power, a sub 1, we get negative 1 to the first power, which is negative 1, times the 1 will give us a negative 1. But in the second term, we're going to do negative 1 squared, which is a positive 1, times 2 will give us a positive 2. Now let's look at the third term. When we plug in the 3 for n, we get negative 1 to the third power. Well, a negative 1 times a negative 1 times a third negative 1 gives you back to being a negative 1, times the 3 is a negative 3. Now negative 1 to the fourth will give us a positive 1, times 4 will give us a positive 4. Negative 1 to the fifth will give us again a negative 1, times your 5 would give you a negative 5. Now notice each time we get the next term, we're alternating the sign here. So we went from positive to negative from negative to positive to negative to positive to negative. We're switching the signs. This is what's called an alternating sequence because we're alternating the signs. So this is called an alternating sequence. Let's look at problem D. In problem D, we have a sub n equals negative 1 to the n minus 1 times n plus 1. So again, we're going to find the first 5 elements of our sequence. So we'll plug in n equals 1, 2, 3, 4, and 5. So we're plugging in our n's for all the n's there. Well, let's see what happens when we plug in an n of 1. Well, on the first one, we'll get negative 1 to the 1 minus 1. Well, 1 minus 1 is 0. And anything raised to the 0 will just give us the number 1. So that's what happened here, is we ended up getting something raised to the 0, which ended up being 1. Well, the other part of this is that we've got a 1 plus 1, which is 2. So we end up with, let's see, a 1 times 2, which is 2. Now let's look at if we use an n of 2. Well, then we'll have 2 minus 1, which is 1. So that will give us negative 1 to the first power, which is just a negative 1. And on our other piece, we have a 2 plus 1 here, which is 3. So we'll have our negative 1 times our 3, which is negative 3. So it's looking like we might have another alternating sequence. Let's see. Let's try our n of 3. Well, we'll get a 3 minus 1 as our exponent, which will reduce to a 2. Well, if we do negative 1 to the second power, we actually get a positive 1. Our other piece of this is 3 plus 1, which is 4. So we'll have our 1 times our 4, which is a positive 4. So it does look like we're going to end up with an alternating sequence. The next piece, we've got a 4 minus 1, which is a 3. Well, we've already said that a negative 1 raised to the third power is going to give us a negative 1 again, times your 5 is negative 5. The next one, 5 minus 1 will give us 4. Again, anything raised to an even power that's negative will still give you a positive 1, times your 6 is 6. So we've got an alternating sequence that's resulting in our answers are 2, negative 3, 4, negative 5, 6. So assuming it continues with the same pattern, the next number we would guess would be negative 7, then positive 8. So it's alternating between even and odds, and as you do so, it's also switching the signs.